So this is FRQ 2026 question number 4, in which we have been given toy X and Y, which are free to rotate about vertical axle. So this is vertical axle, and negligible friction has been given. The upper portion of each toy has radius R naught. So it will look like this from overhead view, that this is radius R naught and constant force F naught has been applied. So due to this force F naught, there will be torque and this toy will start rotating. Rotational inertia of toy X and toy Y is also given. So toy Y has less rotational inertia than toy X. Okay. So initially, toy X and Y are at rest. It implies that initial rotational kinetic energy is zero. And we have already seen that constant force has been applied. During the motion, we have to assume that axle of toy always remain vertical. So this axle will always remain vertical. And constant force F naught is applied by wrapping a string of length L naught. In both the cases, length of string is L naught, which has been wrapped around. Length has been L naught. When the string loses contact with the axle of toy X, its angular velocity was omega x. And when string loses contact with axle of toy Y, the angular velocity was omega y. So in part A, we have to find which angular velocity is greater and why. So let's see part A. See, same force F naught is applied in both the toys at a distance R naught from the axis. So it implies torque, which is equal to perpendicular distance into force. It will be same for both the toy. And then it has been given that moment of inertia or rotational inertia of toy Y is less. So from here I can say it is easier to change the rotation of Y when compared with X. So for the same torque, the object with smaller rotational inertia has greater angular acceleration. And if you see both toy starts from rest and rotate through same angular displacement theta. The string unwind the same length L naught. So from here I can say object with greater angular acceleration will reach greater angular speed after rotating through same angle. So it implies that omega y should be greater than omega x. Now coming on to second part. So second part we have mentioned it here, that starting from work energy theorem, we have to derive an expression for angular velocity of toy x, right? So what is work energy theorem? We have to mention it, that net work done is equal to change in rotational kinetic energy. So this is rotational kinetic energy change, and this is work done by net torque. So what is work done by net torque? This will be equal to torque into theta. This you have to mention. And torque we have already calculated. It is equal to force into perpendicular distance. Once again, we can see here. So this is force and this is perpendicular distance. So torque is F naught into R naught. So this is work done by net torque, and this will be equal to torque into theta, which should be equal to change in rotational kinetic energy. And what is theta? You have to mention that since there is no slipping, I can say theta will be equal to L naught by R naught. So L naught was the length of string which was wrapped around toy. So now I am applying this concept, net work done will be equal to change in kinetic energy. Since initially toy was at rest, its initial rotational kinetic energy is zero, and let final rotational kinetic energy is equal to half Ix omega x square. So if you solve it, you get omega x is equal to under root of twice f naught L naught by Ix. So this is answer to part 2. So in part C, we have to see whether it is consistent with our reasoning in part A or not. So omega x expression, it is twice f naught L naught by Ix. I am taking it here. For omega y, instead of Ix, I should write Ix by 2. So this 2 will become 4. So from here I can say omega y is equal to, I can write this to be 2 into twice f naught L naught by Ix, and this expression is nothing but omega x. So omega y is equal to root 2 times omega x. So this is the relation between them, which clearly says that angular velocity of toy y is greater than angular velocity of toy x. And this is what we have predicted earlier because rotational inertia of toy y was less than rotational inertia of toy x.